Video is going to take you through creating, through linearization and creating a graph for linearization. Okay, so what is linearization? So we have this non-linear relationship because it's essentially it's like y equals x squared. Okay, um, which is a non-linear relationship. So the goal of linearization is to convert the relationship to a linear form so that it can be easily analyzed and you can see um, how well your actual data from the experiment matches the non-linear relationship, because this is a non-linear relationship because it's like x squared relationship. Yeah. Okay. All right. So the way we do this is, so this is the second graph that you're going to need to put in your analysis. So again, just hold down Shift, highlight that. Okay. Then you're going to go Insert. Again, we're just going to do a scatter. Okay. All right, now right mouse click and then select data. Okay, so this time the x-axis is going to be the height. Okay. The y-axis is going to be the velocity squared. Okay, then click OK. All right. Okay, so let's just give it a chart title. So you can go Command A to highlight it all. So this is what height versus final velocity squared. That's just like, I mean, you could go insert a superscript to give you a square. That's just another way. Okay. Then you're going to need the axis titles, horizontal for x-axis. So that's going to be the height in meters. Then you're going to need vertical. That's going to be essentially what the final velocity squared, or you can just go to the power of up to squared in meters per second. Final velocity squared. Okay. All right. Okay, so now, okay, now what you need to do is you need to just select the point, right mouse click, go add trend line, go linear, okay, display equation on chart and display R squared value on chart. Okay, there we go. All right, then these, all right, so what does all this mean? Okay, let's just put that over there. Oh. Okay, it's not growing. All right. Okay, so what does that mean? As you can see, okay, so essentially what you've got is so that's the equation of the line. Okay, that's the best fit basically of your data point. Now remember, this is height versus final velocity. Okay. This r squared, that tells you how accurate your data is. If it's r squared of 1, then you've got no errors at all. I mean, here you can see we've got some slight error. Here we would expect this intercept to be 0, because at 0 height there's 0 velocity, but we've actually got plus 6.3879 here, so some sort of error has creeped in. Could be a number of different things. It could be like the exact point of where you launched the cart. It could be all sorts of things. Okay, so because we would expect that theory to be 0, but we've got a bit of a error there, which is normal. And then this is your gradient. Okay, so y is like y equals mx plus c. All right. Okay, so what your actual relationship is, because here is essentially, because this is your the height is x, final velocity v squared is like your y. So here you can think of this as height here is your x, so it's like x equals to this like v squared. So what you could do is you can see that essentially your it's minus your here, because really it's going to be minus 6.09 x equals y. Okay, that's your actual relationship. So your y is like your v squared here, okay? And then because that's a constant, 19.6 h, well, in this case we got minus 6.09 x. We would have expected this to be 19.6 x, but we didn't, because we've got some errors in our experiment, which is pretty normal. But I mean, these results here are not too bad. As you can see, I mean, our r squared is 0.98, like I said. So it's only some slight errors, but we can see how the actual relationship was compared to our predicted, because we were expecting 19.6, but so I mean we're a bit off there. So yeah, okay.